Under organic chemistry, we get to focus on organic compounds, right? So basically, we are studying compounds that are made up of carbon, more in specific. Okay? So, what did we say? We said carbon basically is able to undergo three different types of hybridization. There's sp, we talked about sp2, we also talked about sp3 hybridization. Okay, so the easiest way of determining the hybridization is by counting the number of connections that the carbon atom is connected to. So for example, if you look at this carbon connected to 4 different bonds, there can also be this carbon that can be connected in a different way. Okay, maybe that one and that one. So there can be one connected with 2 double bonds, 2 single bonds, like that. There can also be a triple bond and a single one there. Okay, so now for the first one, if you look at the first one, what type of hybridization is this? What type of hybridization is that one? What type of hybridization is that one? Help me with the solutions. Help me with the names of these hybridizations. For the first one, what can you say? Hello? Can you guys get me? That's the only problem that is there between you guys and me. Because I'm always delayed in asking you guys whether you're getting me or you're not getting me. I'm asking you, I was asking, is there anyone who missed the previous class? No one agreed. Problem and pressure. Mm-hmm. The type of hybridization is sp3. Then that is sp what? sp2, sp, sp. So for sp we have got 2 types, right? So we've seen that whenever carbon is forming 2 connections, basically it's sp hybridization. So you get to count by starting with s, then pp, giving 3. So what is the shortcut? It doesn't mean that those are p orbitals, but what it means is it's helping you just to come up with a type of hybridization. Okay, is that okay with everyone on how to determine the type of hybridization? Okay, so I want to go into details now and show how all these things come about. Okay, it's becoming more interesting actually, because let's see what we're going to have. So the basic idea, guys, is if you look at what we call the ground state energy level diagram of a carbon atom, you're basically going to have something like this. Okay, you find that if you come up with the electron configuration, you find that carbon has got 6 electrons. Okay, so you have 2 to what? To 4. 2 to 4. Is it 2 to 4? Yes, 2 to 4. So if you get to write it in terms of your orbitals, it's 1s2, 2s2, 2p2, right? Okay, something like that. So the ground states, of course, is going to be, you have 1s, of course, then you have 2s, then you have 3p orbitals. Yeah, this one has got 2 electrons, 2 electrons, then the p has got 2 electrons, so 1 1. Do I have to explain all these things? Because I'm sure you guys we looked at this together, right? You did bonding, you did atomic structure. Not so. So we said for p orbitals it can accommodate a maximum of 6 electrons, s2 electrons. So basically whenever you're dealing with bonding, whenever we are trying to talk about what is formed in what is involved in the hybridization there, you talk about the outermost shell, which is involving these 4 electrons that you can see there. Are we on the same page? Hello? To respond fast, Kai. Okay, something like that. So now, what happens is, in the excited state, there are 3 different things that we can expect to happen. Okay? So I'll give you some examples. For example, in a case where carbon is sp3 hybridized, so we can forget about this part. Let's focus on the outermost part there. So when it's excited to form, to get involved in forming the 4 different bonds, what basically happens is this electron will be excited to go to the other one there. So what you're going to have is something that is going to look like this. So what happens after it's excited is, what is formed is what we call hybridized orbitals. They are going to have the same energy, so they are referred to as degenerate orbitals. Then they have the same size and the shape. So these are called sp3 orbitals. Okay, because it is a mixture of 3 p orbitals that are coming on top here, and 1 s orbital down there. So now this electron, I've said it has moved to the other one there. So each of the 4 will have 1 electron. Are we together? Are we together? That is sp3 hybridization. So now, when for yes, where am I repeating now? Where am I repeating? Where am I repeating? Did you understand where the electron, what happened? One of the electrons from the s orbital got excited and moved. Did you understand that part? And got there, right? So now these guys are combined together, they go there. So we are saying you only get to combine this one and these 3. This is what you have. There are 4 separate orbitals. So they'll be on the same level now. Okay? That's what I said. So some of you may be asking, where has this one gone? It has gone there, but it is now having a single electron because one of the electrons got excited and moved to the other p orbital on top there. Have you gotten it now? Or you're still lost? Hello, respond first so that we move. So what happens, for example, when you talk about 4 bonds there? So what is how the orbitals are formed? So what will happen is, as the hydrogens are coming to connect there, their electrons will be there, forming 4 bonds. So basically, diagrammatically, we get to show this by by drawing the carbon atom on the middle part. You draw it like this. Then you get to put orbitals appearing like that. Okay. So that is the way these sp3 hybridized orbitals will appear. Then it will overlap with the s orbit of the hydrogen atom, because we know hydrogen has only a single electron, which is contained in the s orbital, and the shape of an s orbital is a sphere. So that's why I'm drawing those ones in green like that. So there will be 2 electrons in each connection there. So these are sigma bonds, because we are involving overlapping. We are involving actually an add-on kind of overlapping there. Okay. Are we together? That is an illustration of one of the type of hybridization that carbon gets to form. I can talk about one more to just give you more to see the difference between this kind of what happens. So I was saying this, or there can also be a case where carbon will form 3 different connections, right? So something like this. You have 3 there, and you have 2 s there. So remember, here you have 2 electrons. Okay? You have 2 electrons here. There you have 1, giving us the 4 electrons in the outermost shell, not so? So what will happen for the sp2 hybridization? As you might guess, this one will only involve what? It will only involve 2 what? 2 p orbitals. So what will happen is, this one is a mass supposed to be part and parcel. Okay? So this electron will of course be excited to that part. Okay? So that there will be no electron here. Okay? So the electron will go there. So now we'll get this part and this part. So what will form is, we'll form sp. How many orbitals? 3 orbitals. These are going to be called sp2 because we have 2 p orbitals and a single s orbital. So each having an electron. So now here the difference is, 1 p orbital will still remain there. That is the difference. One p orbital has still remained. So these hybridized orbitals are the ones that are going to involve the kind of overlapping that we expect. Okay. So that one that you are seeing there will now form the double bond, for your own information. Okay. So now, how do you show this diagrammatically? So a very good example is when you have carbon and carbon double bond in between. What basically happens is, you draw something like this, then they overlap. So that is a single bond, a sigma bond. So now for that electron that is there, so remember what you're talking about, this is a one-sided part. Now if you have another carbon, it will also have its own electron that will remain like that. So these again will mix up to form a double bond. So on your diagram, what you're going to do is you show it like this. You draw something like that. So that is like the p orbital. That still has what? That still has the electron. Okay. So there will be just that kind of a connection there. So this represents a double bond, the p orbital. Okay. So now we find that this carbon, if it's sp2 hybridized, it will still be connected to. Remember we are saying it is forming 3 different connections. So this is already a single connection, but of a double bond, of course. So the other connections may have something like that, and something like that, something like that, something like that. So this is usually this is in ethene, for example. You have hydrogen, 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 and hydrogen there. So there will be 2 electrons, 2 electrons, 2 electrons, 2 electrons. So wherever you are seeing the electrons, those we call them the sigma bonds. These ones that I'm showing dots, we call that one as a pi bond. Okay. Are there any questions there? A sigma bond is one that is involving overlapping, like whether they are meeting like this, an add-on thing, where you're seeing two electrons. That is a sigma bond. Even this one is a sigma bond. All these are sigma bonds, except the one we have indicated the pi. Are we okay? Okay. Can I move on now? I was just trying to explain more in details what this type of hybridization basically tells us. So then what else did I talk about? I also made an emphasis on I said when you talk about a single bond, a double bond, a triple bond, how many sigma bonds are there? How many sigma bonds are there? A single sigma bond. How many sigma bonds are here? Single sigma bond. How many sigma bonds are there? Single. Pi bonds? 0 pi bonds. 1 pi bond. 2 pi bonds. So in whatever bond that you're going to have, even when you get to have bonds, what you need to understand is that there's only a single sigma bond there and 3 what? 3 pi bonds. Are we together? That's what you guys have to understand there. Does that make sense? So people are actually logging out and whatnot. The other thing that I talked about is the idea of identifying the type of carbon that you're talking about. So a carbon that is connected to a single carbon and 3 hydrogen atoms is referred to as a primary carbon. Are we together? Denoted by 1 degree. So that is like a primary carbon. The carbon that is connected to different carbons atoms is referred to as what? The secondary carbon. These others will be hydrogen atoms. So secondary, 2 degrees. One that is may be connected to 3 different ones, might guess, is going to be what? Tertiary. Are we okay? Okay. Then the one that may be connected to 4 different ones is referred to as what? Imagism. This is referred to as what? Okay, quaternary. So basically these are the 4 types of carbon atoms that you guys are going to be assessed on. Of course, we're going to be a part where we need to talk about, is it allylic carbons, the vinylic, something like that, if I can remember very well my organic chemistry. Okay. Any questions? So now, these types of hybridization that I talked about, they also have shapes for your own information. So for sp3, that is the tetrahedral. Okay, because you have 4 connections, so it's tetrahedral. Then for sp2, this is something like this. 3 different connections. It's what? Trigonal planar. Then in case where we have just 2 connections, it may be a triple bond, a single bond, or 2 double bonds. That is referred to as, it's linear. Okay. Take note of that. Hmm? Which one is what? The one down there, where it is involved. It's the carbon is forming two connections, either a single bond with a triple bond or two double bonds. Is that okay? Yeah, okay. Let's get move. So I think I've already finished your 30 slides. First part of organic chemistry. So one part is what you need to understand is as we get to introduce the concept of hydrocarbons. What are hydrocarbons? Start with. So hydrocarbons are basically compounds that are made up of carbon and what? Carbon and hydrogen, not so. Carbon and hydrogen only. That's an hydrocarbon, or hydrocarbon if you want to. Okay. So these hydrocarbons are classified into two. Remember I told you to say there will be cyclic ones. Of course, we have what we call the aromatic ones. Aromatic. That is round. Then you also have what we call aliphatic. Okay. So aliphatic would be, these usually turns out to be a chain, okay, with subchains. So that what is, those ones are referred to as aliphatic, then aromatic will be round ones. Okay. Are there any questions so far before I can move on to a different part? Any questions? Okay, I'll move and talk about alkanes. So alkanes are basically under aliphatic. I'll start with aliphatic before I get to talk about the aromatic ones. Okay. So, what do you know about alkanes? So I talked about alkanes. Their general formula is basically CN H2N plus 2. So we said alkanes basically are referred to as what? They are saturated because these guys are only made up of what? Single bonds only. So for me, I don't see the necessity of you knowing that formula. For what purpose? I don't see the necessity. So, for example, if they tell you to say draw the one with 6 carbon atoms, but what is very important for you guys to know is the prefixes. It's very, very important. So know them in this order. There's meth, there is that. Meth, ethane is the third one is what? Is it prop? Meth, if prop. You have that. You have pent. You have which one comes first? Is it heptane or hexane? Then you have hept, you have oct, you have non, you have dic. These are the ones. Are we together? So these ones will help us to name these different hydrocarbons. So for alkanes, they'll end with E, A-N-E. This part, alkane. Alright, so these are saturated because they are only made up of single bonds. That's what I'm saying. So if they ask you to draw hexane, for example, you understand that it's 6. So you just draw 6 carbons, just join them with single bonds. Okay? Then you'd basically know that each carbon is supposed to form 4 connections. So there's this one already. It needs 3 more. I'll add them. So all those connections will involve, you can add the hydrogen. I'll not show them because I don't have enough time. You can show them. Then this one already has 2 connections, so it will need 2 more. 2 more, 2 more, 2 more. The one at the end will need 1, 2, 3 to make 4 connections. So all these lines that I've drawn basically are your hydrogen atoms. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So you have something giving you something with C6 and H14, which can help you come up with a formula to say, okay, I think what happened is I doubled my 6 to give me a 12, then I added a 2 to it, which gives you a general formula there. So no need of you mastering a formula. That is basically the basic concept of these alkanes. So these guys that we're talking about as alkanes can undergo different kinds of what? Reactions. They can undergo addition reaction. What else can they undergo? They can undergo under combustion, where you get to burn them to give you either carbon dioxide and water, or they get to give you carbon monoxide and water, depending on the type of combustion in which they get to be involved, because they can have a burn in complete combustion or incomplete combustion. So there are many more reactions that these guys are basically involved in. Are we together? I didn't basically say any number of reactions. I just told you of 2 already. Addition reactions. There's also, okay, let me just try to listen. So there's combustion, there's addition. So these addition reactions are also called polymerization reaction. Then we also have what we are calling the issue of halogenation, where we get to gain the halogens. Okay, so combustion being 2 types or 2 kinds: complete and incomplete combustions. Okay. Do you have questions? Oh, there are no questions. Are you even understanding the organic chemistry? I'm trying to make it as simple as possible. I don't want to exaggerate things, yeah? Because these things that we have started with are very important to understand. Are we together? Okay. What is the code for chemistry that you're doing now? Chemistry what? Is it 112? Chemistry 112, okay. So we've not even yet posted the notes for the other chemistry part 3. We've just done chemistry part 2. So which means we can still catch up and do some things more. Let me just open the notes. I'm trying to open the notes for part 2. Okay, I also have an account with Mulungush now, so I'm just accessing online to get the notes. You guys were refusing to give me notes, so yeah. Okay, this is nice. Okay. According to the second note, it's not very important for you guys to understand the reactions. We are basically more focused on the nomenclature, which is something that I love about organic chemistry. Okay, so get back to the reactions when it's necessary to talk about them. Let me just try to introduce a part of the nomenclature so that next time as we continue, it will not be something so new to you. Okay. So we already we've already known about the molecular formula, the empirical formula. We know that already. We also did Lewis structures last semester. Okay. So now something that is going to be introduced here is condensed formulas and skeletal. These are the ones that you're going to meet now. Okay. So for alkanes generally, what is important is to note that all bonds are single bonds. Okay. So I'll start by looking at that. So whenever you have something that is like having a Lewis structure in this form, for example, let's say, and remember I've said whenever you have any number of alkanes, right? Whenever you have any number of alkanes, it is something like that, okay? So what happened, guys? This is what we call the molecular formula. Are we together? We call that the molecular formula. It's a molecular formula. Yeah, it's a molecular formula. So for the Lewis structures, of sometimes I see it as something deceiving. Some books will basically just like they'll just put electrons in between to show the bonds, where they'll put electrons like that. So you put the bonds to show the bonds there. You put the dots. We call that our Lewis structure. Are we together? Okay. So now, for the condensed formula, the rule is we don't basically show the bonds. Okay? Bonds are not allowed to be shown. We don't basically get to show the bonds and the hydrogens. They shouldn't appear in our formulas. For example, this one, what you're going to do is you look at the number of carbon atoms. 1, 2, 3. So if you get to draw something like this, when you draw something like that, you've already drawn that entire structure for your own information. That's one thing that I want you guys to know. When I draw that, I've already drawn my what? I've already my skeletal structure. So this is called the skeletal structure. So the key point is at every point, ending point, there is a carbon. Then at every midpoint, whether there is a 10, there is a carbon as well. Okay? That's what it means. So the hydrogen are not supposed.
So it's just to draw something like that. So in short, whenever you're coming up with a skeletal structure, you focus on the number of carbon atoms that you have in the order in which they are arranged. Okay. So now, assume I did something like this. Here I decided to add maybe, at this point I had a carbon, right? If I had a carbon there, it will imply this is supposed to be connected to 4 other things. What I'll do is, first of all, I'll draw something up to show these 3 ones, the first 3 first of all. So I can draw even down here so that I can have a space down.
So there's a bond, there's a carbon there, there's a carbon here, there's also a carbon there. 3 already. Then if I push it down, it shows there's also a carbon there, already representing the 4 carbons that we have. This tells us to say that the one that is on the middle will only form 1 hydrogen bond, but we don't show the hydrogen bonds. We only draw that. That is enough. Any ideas now? Do you have an ideas on how we come up with skeletal structures? Do you have ideas? Hello? You don't have ideas? Camufere poi firifionse. Fondandire. Okay, my class ends here for tonight. Go and relax. You watch a recorded session, maybe you understand. Yeah. I'll draw in. So I'm saying, just look at the number of carbon atoms. You have 3 there. So you just draw like, at the end, I'll just draw something like this. So at the end there it shows there's a carbon, there's a carbon, there's a carbon there. So I do another line. Why am I adding it? I'm adding it on the middle one because it is on the middle carbon there. So I'll show it down. Yeah, that's all. I've shown all the carbon atoms. So if I can remove that carbon on the middle there, and then I get to add another on this side. So we have 4. So instead of it just ending like this, because this is already showing 1, 2, 3, I'll just draw another line this side. Like that. There are already 4. If I add another one there, I'm required to do another one this side. If I add another one, I'll add another one. If I can add another one this side, I'll add another one. That's the way. That's it. So that's simple. If I join it on this carbon, I join another carbon down. It means that I'm on carbon 1, 2, 3. Carbon 3. So 1, 2, 3. So I'll join it just up there to show that there's a carbon on carbon 3. If I can add another one, maybe down here, I will just put it up there. If I can add at the end, or maybe this one, second from last, I'll just add it there. So it's like the carbon atoms are just represented by at the end points and also every point where there's a 10. That's what it means. Are we together? Yeah, so you guys are stressed and I don't know what's up. So you can just take some rest and maybe try to watch a recorded session. You'll be able to follow. Okay. So for tonight we end there. So I get to talk about naming them now. Advanced nomenclature. We need to understand how we get to name them. So if we can finish that next time, then we'll be warm and dry. And then we can focus more on the previous topic for now before we get to continue, because organic chemistry is broad and yeah. Okay, so good night guys. Just hope that you rest and then get back to the video.